In your book, Chad, you describe data debt, something that we haven't talked about yet, data debt, as a primary villain in data management. So maybe, yeah, in if your book were a novel, this would be the data contract is the superhero, I guess, out to get the data debt villain. And so, yeah, data debt can be a huge problem in data management, impacting data quality and data trust. So, again, this seems like a term that could be borrowed from software engineering, where we talk about technical debt in the code that we develop, and you kind of have these lurking surprises that could get us in our software development. And so, it sounds like data debt might be similar. How do you define data debt?
I think it is similar. So the interesting thing is that a lot of the patterns we're talking about, whether it's data debt and tech debt, or data contracts and service contracts, um, or even data quality and code quality, all have a relationship to each other, but not because I think that data is inherently very similar to software engineering. It certainly does have a lot of similarities, but there's actually a larger category of change management, regardless of what the system is. We could be talking about applications, we could be talking about data, we could be talking about, real world systems, supply chains, for example, where you've got a farmer that's harvesting wheat. They are handing that wheat off to a manufacturer that is turning it into something interesting and useful like cereal. And then that itself is being handed off to a retailer to sell to customers. The supply chains actually have the same exact problems as data pipelines do, which is why I've been calling them data supply chains instead of pipelines for the last couple of years or so. There's still many people who may not potentially speak to each other. There's quality issues that could be introduced, which could be really bad. And there's also contracts. So this is very common in the manufacturing space where, a farmer needs to have a contract with the distributor because the distributor needs to specify, hey, if you give me a certain quality of grain, I am not going to be able to sell that to my customers who can turn it into something consumable for a human being. So there's a certain quality threshold that has to be set. So all of this sort of around change, around handing off materials and data and code between people, I think it's part of this larger sort of category. So that's just what I wanted to preface that answer with. But I do think software is more sophisticated than data when it comes to solving, or they have better language when it comes to solving certain types of problems. And tech debt is definitely one of them. So in software land, tech debt is all about we have made certain software choices at particular points in time. We knew when we made those choices that they weren't going to account for the long-term scale of the company or the long-term needs of the company, but we just needed to go fast. And at some point in the future, that debt has to be paid. You do reach that scale, you do reach those long-term needs, and now you have to address it. So the real potential, problem with tech debt is that it slows your business down to a crawl as you need to address all those earlier decisions that you made before you can move forward. Data debt, I think, is a little bit different than that. Data debt is when data changes in some way, and the teams responsible for consuming that data don't correct the underlying systems, but add their existing expectations on top. So we say, okay, I've got a user table, and I've got a first name field, and I've got a last name field. And the producer decides I'm going to join that together into a single name column. Well, now downstream, I, as the data consumer, suddenly all my data is wrong. And instead of going through my entire pipeline and fixing everything to reflect the new world that the data producer has created, I'm just going to add a filter on top of my query that says, hey, look, I want you to just slap these two things together. Just do a merge and sort of stick first name and last name together and cram it into one shape. And what happens over time is you get these really, really long, complicated SQL statements that no one who wasn't there when they were written can possibly understand. Or you get massively long databases or massively long tables where you have column after column after column after column. And if you were to ask the creator, the original creator of that table, what it means, they probably wouldn't even be able to tell you an answer anymore. This is sort of what I call data debt, when the initial meaning of the data incrementally becomes lost over time. And personally, I think this is worse than tech debt, because tech debt slows you down, but data debt causes you to lose the initial lose sort of your grasp on the initial intent of the information being conveyed through the data. And that intent of information of conveying that information is the entire purpose of using the data in the first place.
Well said. Is something that makes this data debt even maybe accrue more quickly or more problematic, this spaghetti data architecture that you've talked about on previous podcast appearances or talks that you've given.
Mm.
Yeah, tell us about this spaghetti data architecture and what the root causes are.
Well, the spaghetti architecture is really a result of data debt forming over time. So
I see.
when you have the spaghetti SQL, that's sort of the end state where all the code that you've written doesn't really make sense anymore. It's all over the place. You've got copies of data in multiple places. You've got the same concept that people, think looks the same, but it actually means something different. And you've got different definitions of things. And that is really a result of unmanaged change. So something I've said on a few on conferences and talks that I give is that if nothing ever changes, nothing ever breaks, and that means that quality is actually a result of unmanaged change, and that means the data quality problem is actually a change management problem. And so when you don't have good change management, then changes occur. People react to that change. They react to it in a suboptimal way. You start to build the spaghetti SQL over time. And at a certain point, it's so complex, it's so difficult to sort of pierce, it's so opaque that it's very hard to move forward.
hmm Are data contracts a solution that completely in and of themselves solve this spaghetti data architecture problem and the data debt problem?
I don't think so. I don't think a data contract by itself can solve that problem. I think what the data contract does is that it opens the line of communication between a producer and a consumer in a way that didn't really exist before. The In my last role at Convoy, I actually went and talked to about 30 or 40 software engineers, and I asked them, "Hey, how can I get you to care about the data that you produce from the perspective of analytics and machine learning?" And that's not to say they were doing anything wrong by not caring about it. But I needed to know. And the answer they told me is, well, I need to understand where my data is being used. I need to know who's using it. I need to know what they're actually using it for. And once I have that information, then I can start making better decisions. And because the data producer, to them, the data is effectively going into a black box. That's your analytical database or your Databricks or your machine learning environment. It's a black box to them. They can't see into it. They don't know what's happening. If they start to see, oh, my data is being used in this place, in this place, in this place, and this place over here by these teams, when I make changes, now I know who to talk to. And when you start to open that up, you start to actually have conversations. This is when you start falling into Conway's law. So I don't know if you're familiar with Conway's law, but it basically says that the communication structure of an organization is what ultimately it ultimately becomes a reflection of its architecture. So your actual applications and your services and your systems and the way people build products and write code is based on the communication patterns that exist in your company. And right now, the communication pattern between the teams that create the data and use the data is non-existent. And that's what the contract opens up.
Nice. I hadn't heard of Conway's Law, but I will be reading about that more and including
Hmm.
a link to it in the show notes because that makes a lot of sense to me. That if I got that right, or if I get it right, the idea of Conway's Law, to repeat it back to you, is that the the ways that we set up communication in our organization end up determining the quality of the communication in the organization.
That's exactly right.
Yeah. Okay.
There's sort of a famous infographic where they basically lay out the communication structures at various companies and then show how those communication structures directly map to the way those companies actually built their software. Like Facebook has more of a mesh style communication structure, and their product with the way that the microservices communicate to each other is more of a mesh. So it's a really fascinating idea, and I think that it affects the data world incredibly, because data is so it can't exist in isolation. It's not like software, right? Like a software engineer can go out, they can build an app, they can write requirements, they can deploy their code, and as long as it doesn't, do anything, as long as it's not incredibly broken, it will more or less work just fine. And the software engineering industry has been pushing engineers to become more isolated over time, right? With microservices and sort of smaller and smaller team sizes and sort of working on these more individual product components and so on and so forth. But data doesn't work like that. Like data can't exist in isolation. Data has to come from somewhere, and then it has to be transformed by someone, and then it has to be used by someone. And usually it's not the teams that are producing the data that are also the ones creating the models for it. So if that is the case, then it's so critical to create that information bridge and allow these teams to work together better.